Which one of you have heard of hexagonal architecture before? Okay, most of you, most of you. Which one of you has used it before? Okay, that's a lot less people. That's good, and maybe some of you can learn something today. So I'm going to talk about hexagonal architecture today. Yeah, the term originates from an article that's written by Alistair Cockburn in 2005, and yeah, it's also sometimes referred to as ports and adapters. Yeah, I'll get into that a little bit later. Why? But yeah, we'll talk about how to build maintainable future-proof applications using hexagonal architecture. So first I'm going to talk a little bit about yeah, why software architecture is important, very briefly, very short, and about layered architecture, which yeah, I think most companies are using in most of their applications. So I'm sure it will look familiar to you when you see it. Then a little bit briefly about hexagonal architecture, the pros and cons, when to use it, and clean architecture is a term that's probably also familiar to most of you. What are the differences, just very briefly. Then we'll dive a little bit more into the hexagonal architecture, the details, talk about ports, adapters, testing, use cases, mapping, organizing the code, and how we can enforce the boundaries. Okay, then we'll do a little bit look at some code. If we have time, we can go into that. Okay. Yeah, why is software architecture important? I'm sure most of you probably have worked on legacy apps. Stuff is going through each other. If you change something in one place, maybe something in another place breaks. Or maybe in your own application, you start nicely, but then you cut some corners and then, yeah, shit hits the fan. Yeah, so that's why you need to think about how you're going to structure your applications. It's very important to have maintainable applications, to have flexibility, adaptability. If you want to make a change, you don't want to break something else. And you want to have scalable apps too. So first we'll talk a little bit about what's the layered architecture, probably very familiar to most of you. There's like a presentation layer. Sometimes it's not directly part of the application, but it's kind of an external thing. Then there's usually a web layer, which is your controllers, a domain layer, which should contain the business logic. More often than not, in my experience, the business logic doesn't stay in this layer. It leaks out in the other layers too. But yeah, this is kind of where it's supposed to be. And then there's a persistence layer, which yeah, saves things into some kind of storage, usually a database. So the pros and cons of layered architecture, well, it's easy to learn. There's a low overhead. You can just write some stuff. You don't need to have any kind of yeah, mapping or set up boundaries. But the cons are it promotes a database-driven design. So usually you will start with your entities, and yeah, they end up being used by the entire application, which could be a bit of a problem sometimes. Another problem is it can hide the use cases. So you might have a controller that's kind of like a God controller that does everything, or like controls everything, like you call everything from there, and everything is kind of like running through each other, yeah, which can lead to some problems too. And it can be hard to extend or adapt, so you can be a problem to add new functionality or change existing functionality. Then hexagonal architecture. We have an outside layer, it's an external layer or infrastructure layer. Usually it's also not directly a part of the application. Could be a database, could be like a front end or whatever, or a queue or something, Kafka topic. Then there's an adapter layer, which is basically adapting from the model that's used by the external component to the model that's used by the actual application. So the inner two layers, the application layer and the domain layer, is basically where all the business logic is contained. So the domain layer contains the models, and then the application layer, well, and also, depending on how you structure it, some of the business logic, and then the rest of the business logic will be in the application layer, as well as the interfaces to the outer layers. So The pros of this is it's easy to maintain and expand because, well, you have a clear separation of concerns. You separate your use cases also, so it's easy to add a new use case. It will be completely separate from other use cases. The business logic has no ties at all to your infrastructure if you set it up well. So you can easily change your infrastructure without impacting the core of your application. And then, you have improved testability because, well, your tests, you can just test your use cases without testing your infrastructure components. As you see here, also the arrows point inwards because, you don't use outer layers in inner layers. So you have, basically, this is the D in the solid principles, so dependency inversion principle. Which also creates nice separation. Some of the cons of it, it does have a significant overhead in code. So if you are, if you have a very simple application, might be a bit overkill. It does have some higher complexity. There's a bit of a learning curve when you start using this compared to the layered architecture. And the initial design might take a little bit more time because you need to think about it a bit more. Yeah, so when to use it, I already mentioned a little bit. If you have a very simple application, probably hexagonal architecture is a little bit overkill. But basically, it depends, right? This is the answer to all the engineering questions. So you need to have an application that has sufficiently complex business logic, volatile infrastructure. You might want to change, I don't know, from a MQ to a Kafka topic. You might want to switch out a Mongo database for a Postgres database or whatever. You can do this easily with hexagonal architecture, so that's a great use case for it. And it must be highly extendable. So if you add a lot of new use cases to it, you have a lot of complex business logic. It's a great use case for hexagonal architecture too. Okay, what about clean architecture? Well, clean architecture is a term that was coined by Uncle Bob, Robert C. Martin. I'm sure most of you are probably familiar with this guy. He wrote some good books, recommend reading them. Basically what clean architecture is it takes most of the principles from hexagonal architecture and then builds up on top of them. I'm not going to go into all the details, it's out of the scope of this talk, but I recommend looking into clean architecture too if you haven't already. It's a great book, a lot of useful components in there. Then maybe some of you have also heard of the term onion architecture. This is very similar to hexagonal architecture. There's less of a focus on the adapters and ports, more of a focus on the dependency inversion. But it's more or less the same thing. All right, then let's get into the nitty-gritty a bit more. So ports and adapters. As you can see here, we have adapters on the left side, adapters on the right side, and then input ports, output ports. So basically we have our input ports. They're also referred to as driving ports. This is what's driving the application. So you get something coming in. The port is kind of the access to your application core. Then you have a use case, and then this use case will call the output port, and there will be a persistence adapter, for instance, that's implementing this port that's connecting to your database or whatever other way of persistence you're using. The good thing about this also is you can write multiple adapters for the same use case. So for instance, you have maybe you want to have multiple users, let's say, of an application. Some of them, they might have, an email as an input, or some might have a queue as an input, or maybe just a REST API. You can use the same use case, you just need to write a new adapter for it. And you can also write mock adapters, which we'll get into in the next slide, for testing. As I've already mentioned before, you can easily test this because you've got all your business logic completely decoupled from your infrastructure. So that means that actually you can write an adapter that's only used in your test layer. That's calling your port, that's calling your use case, and then on the other hand, you have the driven port, that you can write like a fake implementation or a mock implementation for too. And this way you can test all your business logic very easily. One way to do this is by using a double loop TDD approach, for instance, where you first write an acceptance test, can even be a BDD test. In fact, I would often recommend it. Then you write a failing unit test and make the test pass, refactor, until your acceptance test eventually passes too, and then you're done with the use case. Okay, so use case. So I mentioned before, your use cases are completely separate from each other. This concept is also sometimes referred to as vertical slicing. So you have the layers, but then you also have the slices that go through all the layers that are separate from each other. So you can write, your use cases in this way. They're completely separate. And so. All right, the next one, mapping. So basically, if you don't want your application to be using a database model throughout the whole application, then you probably want to do some mapping. So there are several strategies that can be used. First one is the no mapping strategy, where, well, you don't do any mapping. Disadvantage of this is that probably you will have to put some kind of annotations or some kind of database logic in your domain model, which is a bit of a smell, so I would not recommend this strategy. Then there's a two-way mapping strategy where you map when you are going into your application core, and then again when you're going out of your application core. So you have a web model, a persistence model, and then your domain model. Another way is a full mapping, where you first map to command or a query, depending on your use case. Then this one will trigger some business logic to probably create or fetch your domain model. And then you have another command or whatever going out. So basically your domain model doesn't leave your application core at all. This, most of the time, it's a bit overkill because you need to do a lot of conversions. But it can be useful in some cases. What I would recommend most of the time for a little bit more complex applications is kind of a mix of both, where you use commands and queries for your use cases that have manipulation. You would use a command, like for instance, create something. For use cases that only fetch data, you would have a query. This way you can have a little bit more, it's a little bit easier to see what's going on in the application, basically. And for then actually persisting your domain model, you have a separate persistence model, but you don't need to convert your domain model to some kind of, I don't know, update command or save command or whatever before you persist it. You just map it to the database entity and that's it. Okay, then talk a little bit about organizing the code. So we talked about the layers before. You have basically an adapter layer, an application layer, a domain layer, and then here I have a config layer too. Basically all your models, you want to put it in the domain layer. In the application layer, you put your use cases and the implementation of them. And in the adapter layer, you have, well, the input and output adapters. This is not like a fixed rule. You don't need to stick to this exactly, but it's a suggestion. You want to keep, you at least want to keep the package separately. You can still put them a little bit inside each other if you want to. Sometimes you see the domain layer inside the application layer. But yeah. All right, architectural barriers. So basically you have these nice layers, you have this nice separation, but you don't want someone to be like, oh, we need to meet a deadline, let me cut some corners and then leak some layer to some place where it's not supposed to be. And to do that, you can set up, or to prevent people from doing that, you can set up certain barriers. So ArcUnit is a great tool to do this. Basically, what you can do is you can say, okay, I want classes in package A, for instance, the application package. I don't want them to be able to use anything that's outside of the domain package and the application package. So nothing from the adapter layer can be used in that classes. If you do that, then your test will fail, your build will fail. You need to go back to the drawing board. So you can do a lot of stuff with ArcUnit. I will not get into everything. Some of you maybe have heard of Spring Modulit. This is using ArcUnit under the hood, so it's quite a powerful tool. If you want to do stuff like this, I would recommend to give it a look. All right, then let's look at some code. Oh, fuck. Yeah, there we go. So is this okay to see for you guys? Looks like, right?
If you will open the document, it will tell you.
Yeah. Okay, so first again, packages. We have adapter layer, application layer, and a domain layer. First, yeah?
Can you make it a bit bigger?
I can try. How do I do this again?
You can do shift and presentation or shift appearance.
Appearance. Oh, there we go. Okay. How do I get back to my... There you go. Okay. Okay, let's have a look first at the domain then. So this is just a simple application that's kind of like a little bit like a basic web shop. So we have our order. Oh, this is a bit big. There we go. It's okay to read, guys, right? Yeah. Yeah, so we have just a basic order. It has an ID, it has a user ID, and some other attributes. Yeah, nothing fancy. And yeah, as you can see, it's just a class. We have put some Lombok on there because I'm lazy, but other than that, it's a very simple thing. Then in our application layer, we have here the ports. So we have ports in, ports out. So these are actually the use cases. So for instance, we have a place order use case. Well, it's just an interface. It's being used, or it's being implemented by, it's being implemented by the service, which is then in the service package. So yeah, as you can see here, we just have a command coming in. We are, yeah, it's containing a shopping cart. We're getting some items from the shopping cart. Yeah, the items we are getting from the output port. So the output port, I think I actually did make an implementation for it, but basically, oh yes, basically this is just yeah, your standard persistence thing, and you have a repository, you make some use of it. But this is completely separate from the inner layer. It does not know about the existence of this implementation, it only knows about the port. So now let's look at the tests. So I made some BDD tests for this. So let's look at the, for instance, or place order here. So can I zoom out? Yes, it's still readable. Yeah. Yeah, so basically what I did was first I wrote some scenarios I want to make a use case for. Yeah, I think probably most of you have seen a test like this before within Gherkin, implemented with Cucumber. Basically what you do is, yeah, you just prepare everything like a black box test, and then you call your port. So let's go into that. I place the order. So what I have here is just my port, and then, or sorry, this is just my port. It's called, and then I have here a specific implementation just for the test of the adapters, or sorry, just the driven adapter actually. Because the other one I don't need because I'm directly calling my use case from the test class. So basically this allows me to only look at my application core for the test of the business logic. Don't need to look at anything else. I have my own fake implementation here, which I would actually recommend to write before you start writing any actual infrastructure implementations, because you can basically finish your entire app before making any decisions about, oh, what database I want to use, what, I don't know, input I want to use, which allows you to delay decisions until you have the knowledge to say, okay, I have this kind of load, I have this kind of stuff, so maybe it makes sense to use, I don't know, a Kafka topic, or maybe to use a Mongo over a Postgres or whatever. Then I will quickly show just a very simple arc unit test. So basically, I define the packages that can be used by all layers. So here it's the domain layer, can be used by all layers. Of course, basic Java stuff, and well, I added Lombok. For the application layer, I'm allowed to use, well, also the domain layer, the Java stuff, Lombok, and the application layer. When I'm so basically, I can easily restrict which packages each layer is allowed to use. You can even do things like if I don't want my domain model, for instance, to leak out of the application, so I want to make sure that it's mapped in some kind of way to reduce dependency on external components. Then I can say, okay, I don't want methods to be able to return classes inside the domain package. So you have a lot of options with this. I will not get further into this. There was one more thing I believe I wanted to share. Oh, right. So basically, just for the case of this this demonstration, I wanted to make sure that I don't use any Spring inside my application core. So that means that I will need to generate the beans manually, but that means that my application core is completely free of any kind of framework. So yeah, you see here I'm creating the beans, but they are just created outside of the core. So this is not necessary. You can also use Spring if you want to, but it's just showing like you can keep it very clean of outside of dependencies. Now I just use Lombok basically because I'm lazy, but you can also say, okay, I don't want to use any dependencies outside of just what's in the normal Java library for my application core. So that's basically it for the code. Let's go back to the presentation. So then recommended reading. I already mentioned the original article written by Alistair Cockburn. It's very short. Yeah, probably will not tell you much new now that you've heard this presentation, but might be interesting just for reference. Then the Clean Architecture book, of course, it's yeah, probably known by many people, if not most people. The other two, Get Your Hands Dirty on Clean Architecture and Designing Hexagonal Architecture with Java. They are a little bit more hands-on, so they go a little bit more into yeah, how do you actually implement this, whereas the Clean Architecture is a little bit more theoretical. So yeah, I would recommend if you're interested and want to know more, have a look at those books. You don't need to read them completely. The middle two also come with some GitHub repos where you can get a better idea. And yeah, if you want to, oh, that was wrong. There we go. If you want to have a look at my repo, you can scan this QR code or reach out to me and I'll give you the link too.